Thank you very much for joining us here this morning at our Innovation Demonstration Center. My name is Stanley Yee. I'm joined here by my colleague Brent Dull. We are with the Dow Corning Corporation, and we are going to demonstrate the application and installation of our air barrier system. It's titled under the Build a Better Barrier program and system that we're calling, and the air barrier itself is called DefendAir 200. It is it's the only silicone water-based air barrier out on the market right now that comes with a series of accessories and complemented by a similar warranty system that's backing the whole system. What I'm going to be doing here for the balance of the demonstration here is to walk you through each of the steps, probably provide you a few of those key points that you'd be looking for in the product itself, in the applications. Brent's going to be starting this whole process. It's a fairly short program that we've got here today. There's a lot going on. So before I forget, at the end of this program, if you have any questions at the end of this, we'd be happy to field them. And if we run out of time because we need to move on for the other demonstrations, please feel free to stop by our booth in 926, aisle 9, and we're number 26, right down here in the middle aisle over here. We're going to start with preparation of your substrate. You want to make sure that it's sound and clean, and just kind of brush off any dust. And like on any project there are going to be penetrations. We have seldom come to a project where it's completely flat wall, and to ensure that you provide an airtight system, you have to be able to take care of your penetrations and be able to seal around them. Traditionally, they're mostly done by sheet goods. Here you see that Brent is demonstrating that it is a very simple application, and it's a simple application with not a very with a 791 weather seal. It is our very standard and very typical glazing industry weatherproofing sealant. And as you can see, it's a very simple application that goes all the way around. If the joint between the penetration and the sheathing product is a little bit wider, then you might want to consider a backer rod. In this instance, it's not required, and it's a very quick application of just the black sealant, the 791 sealant that Brent's putting on, and tooling it all around. The vent flue that he's working on right now is typically, they can be round. I've seen them triangular. Mostly in this instance it's square, and as you can see, the ABS or PVC pipe that he's working around over there, those are typically vent flues or pipe penetrations for water or gas. And again, those penetrations are typically the culprits for large and uncontrolled air infiltration. And then you proceed on to, once you've taken care of your penetrations, and the thing to remember is that the sequence that we're doing it here isn't actually necessarily the sequence that has to be done on the job site. So the next step that we'll be taking here today is treating all the sheathing joints. So they typically, sometimes they're tight, sometimes they're done really nicely by the trades, and more often than not, they're not. And those are opportunities for uncontrolled air infiltration. And we would take, again, it's the same 791 weatherproofing sealant, and treating all the joints, both horizontal and vertical. Again, it's a straightforward bead all the way up the joints, and then striking them flat. At the same time, all those penetrations, all those fasteners that we use to hold the sheathing up. In this instance, it's a fiberglass-faced gypsum board. The screws or the fasteners will need to be treated as well. And again, we'll be treating it with the black 791 material that Brent has. Again, here you can see that he's just striking flat that straight joint and moving the extra around, and the extra doesn't have to be scraped off. You can basically and go over the fasteners with some of the extras. So typically, this would be an exercise done by your detailing crew all the way around the building, and ensuring that the general wide field is done. So now we've taken care of the penetrations, we've taken care of the clear fields. there's always those instances where we'll have changes in plane. And then we have changes in plane, like where you have exterior insulation or an edge slab, where you would want to put a lintel to support some brick veneer work or other type of cladding, or even in a window wall application, you would have this change of plane. And to ensure the continuity of that, because again, the air tightness of your wall is going to rely on the continuity of the air barrier system that you're putting in. It's not just the air barrier product, but it's all the components that go along with it. And what we have here is we're going to be using an extruded silicone sheet called the silicone transition sheet. I have a 12-inch wide sample right over here that I'll pass around. And what Brent's doing over here, and he'll be using. Is it struggling? What Brent's doing over here is he's using our 758 sealant, and or he's trying to. Oh, there we go. 758 sealant, which is another weatherproofing sealant, and then we'll be talking a little bit more about the 758 in a moment. But he's using this sealant to adhere the flexible flashing. So again, it's one of those instances where it's an all sealant, all adhering application. There's no screw guns, no screwdrivers required, simple cutter. And as you can see here, it's a quick operation of being able to just lay down the silicone strip right on top of the 758 weatherproofing sealant, and just remembering that, and to press it down to take all the gaps out. You have to remember, the seal is only as good as we achieve the continuity. And to achieve the continuity, you want to roll it out flat, and a simple process of just either using your fingers, or in Brent's case over here, he's using his tooling spatula, and at the same time, you notice in one single motion with the overflow of the sealant, he was able to also provide that top edge seal, what I call a toe bead, to be able to complete the seal at that transition. So that now we've set ourselves up for success in terms of being able to make that transition from the sheathing wall to the STS. To complete the transition, Brent will have to apply the STS onto the air vapor membrane, which is located below. It's identified as this blue product over here. This is typically found on a lot of foundation walls or even slab edges. This is just to demonstrate how it's accommodated. And again, he's using the 758 sealant. This sealant is a silicone sealant. It was specifically formulated to provide adhesion to polyethylene-backed materials. As you well know, polyethylene-backed materials is very slick, very low energy. There's not a lot of adhesives that are going to be able to accomplish that. This is a product that was specifically formulated to achieve that adhesion and achieve that adhesion reliably. As you can see, again, it's a very simple process of being able to apply that bead of sealant and then to press the STS, the silicone transition strip, right over it. And again, as you can see, that Brent's demonstrating that it's a simple process to be able to strike it flat and to also achieve the all-important edge bead that completes the seal. So now you can see that we've completed our penetrations, we've completed our clear wall, and we've completed our transitions to either edge slabs or to other components. If you looked at this particular condition that Brent just finished and we turned it upside down, it's miraculously all of a sudden a parapet condition, isn't it? It's top of a building. Again, where you have that polyethylene back membrane material, you should be able to achieve that. Various different types of details and ways and means of being able to accomplish that closure. But again, you have the basic materials, you have the basic concepts, and we at Dow Corning are perfectly ready and willing to have the conversation to talk more specifically about your particular project needs as they pertain to those specific details. So now that we've taken care of all those components, rough openings, windows, The great thing that we love about our buildings these days is that we have the opportunity to open them up, provide some fenestration to provide some daylighting. But before we actually get there, we want to ensure that the building enclosure is again continuous. And as you can see, again, we need sound and clean substrates, and Brent just kind of just brushed the dust off the rough opening. And we are going to introduce our liquid flashing material. And this helps to complete that transition between the rough opening and your clear wall. And this 778 liquid flashing material was specifically formulated, it's a sealant, it's a silicone sealant, it was specifically formulated with longer open time. Traditionally, weatherproofing sealants have an open time or a workable time of about 20 minutes depending on environmental conditions. In this instance, this particular component was designed to have a working time of about 1 hour. Viscosity levels a little bit lower, and it was designed to be less stringy. As you can see, all Brent had to do was basically extrude it out of the sausage and the caulking gun, and in a squiggle, your traditional squiggle fashion. And right now, all he's doing is just tooling it out. And traditionally, in conditions like this, we would expect a weatherproofing sealant to start skinning over a little bit and start getting stringy. And as you can see here, it's very, very akin to icing a cake. That's kind of how I like to describe it. It's very simple spatula motion, and as you can see, Brent's getting very good coverage. It's the requirement of anywhere between 25 and 28 mil thickness material. And he's coming up in a more traditional fashion of coming up the vertical of your jambs by about 6 inches. And it needs to come out on the face of the wall, as Brent's applying right now, by 4 inches. So as you can see, he starts with the horizontal components. Again, this is silicone. It's all compatible. It doesn't matter what sequence you're putting it in. If it just so happens on the job that the sequencing doesn't allow him or allow your project team to be able to put your liquid flashing on before your air barrier, doesn't matter. You can put on your air barrier first and then come back and be able to detail these later. Why? Because they're all silicone materials, they're all silicone-based materials, they're all compatible, and when they all cure and set up and dry, they work as a monolithic team. And that team is what provides that air tightness on your building enclosure. So as you can see, as Brent wraps up and finishes out what I call the 6-inch saddle, in some instances on different projects, you do have the opportunity, or you can explore the option of actually using the 778 on the entire rough opening. It can go all the way up to the top, and you can run it off on the soffit. And actually, the green strength, particularly of the 778, is good enough as it is extruded. It actually does a better job at staying in the overhead condition long enough so that you can get a spatula and tool it. So from that perspective, it's a very technician-friendly application. In the instance that we're demonstrating over here, again, we're just coming up 6 inches on the vertical wall. And in this instance, when we put on or when we apply the DefendAir, the DefendAir would be wrapping around the rough opening on these two flank walls. So now that we're done with the penetrations, the clear wall, our transitions at the floor slabs and horizontals, adhesion to negative surface energy materials like spun-bond polyolefin, that's a mouthful, and polyethylene-backed self-adhered membranes, it's now time to apply our DefendAir 200 fluid-applied silicone barrier, air barrier. And just for comic relief, I promised myself I wouldn't do it, and of course, within 5 minutes, I did that. So, so Brent, we're going to turn this around. You got it, Brent? So we're going to turn this mock-up around again, and as you noticed, this was the part of the wall that Brent had treated the vertical joints, vertical and horizontal joints of the sheathing, as well as the fastener heads. For expedience, Brent has pre-treated the top of this board, and The air barrier, the silicone air barrier, the DefendAir 200 is a water-based fluid-applied air barrier, low VOC formulation. So it's actually very green and sustainable from that perspective. 26 US perms, and so it's vapor permeable material. It goes on, because it's 50% water-based, it goes on 30 mils thick, and it dries to it dries to 15 mils. So I'm going to pass around 2 samples here. Just one side over here, one side over here. Yeah, okay. So it's at 30 mils wet. So when you spray it, you can do that on one pass. When you roll it, it's going to be 2 coats. Now, given the time constraints that we'll have, we're probably only going to be able to put 1 coat on. But the process that Brent's doing over here is it's very simple to basically repeat for the second coating. That's how you achieve the 15 mil dry film thickness, or the 30 mil wet. So again, it's a vapor permeable formulation, primerless adhesion to most substrates. And this, in commercial construction, this being the most popular one, it's most certainly primerless adhesion to fiberglass-faced sheathing material, gypsum-based sheathing material. The system that we had just demonstrated here, all the components, the weather seal, the penetrations, the liquid flashing, the transitions at the base of the building, have all been tested and certified and demonstrated to exceed performance requirements identified by codes and standards and various regulations. Again, being a silicone-based material, the advantages of silicone being a non-organic, it can be left exposed for a longer period of time. In fact, what we could call unlimited time. So take, for instance, where you have a project where it's go, go, go. We need to get weather tight, but the cladding components haven't really shown up yet, but they want to be weather tight so they could start doing interior works. This air barrier material, because it's silicone-based and it does not experience UV exposure degradation, it will provide that project additional time to be able to. So organic materials, you would typically have 30, 60, maybe 90 days. Again, you could put this on and back out and basically say, contractor, I'm done. It's watertight and it could be exposed, and somebody could put the cladding on at any point in time. So what Brent's going to demonstrate here is we're going to assume that we had time to put on the second coat, but he's using the wet film gauge thickness that's in that sample that's being walked around. And so, it's a very simple process of just right after you apply, you just press down onto the wall. And how many mil thickness on your first run?
It's touching the 14, but not the 16.
Oh, so it's 15 mil wet thickness. So that was the first coat. So he puts another second coat of that same thickness, and bang, you're spot on. You hit your 30 mil wet, and it will dry to 15 mil wet, 15 mil dry. No, okay, close enough. Average. So that basically wraps up our presentation here today for you.
And again, no order of application doesn't matter.
As Brent was just mentioned, the order that we did it was not necessarily the way that you have to do it. The sequence of application does not matter. It is completely independent of that because it's silicone materials and they play around with each other. The temperature extremes, the great thing about the DefendAir, although it is a water-based, it can be applied in temperature conditions as low as -6 degrees Celsius. So for a water-based material, that's probably very atypical, but that's very powerful in the climate that we're in today. So in conditions like today, you would still be able to apply this DefendAir 200 system, as well as all our other silicone materials, despite the fact that it's water-based. The drying time, again, it's going to defend. So the DefendAir is water-based. It's so you're going to want a little bit of heat. It's about 24 hours. So you'll want.
It's an
At most, it's about 24 hours at most. So when the weather, environmental conditions are a little bit warmer, that'll be much faster. You can actually, yeah, as Brent said, you can get 2 coats in one day. You can get the first coat in the morning shift and the second coat in the afternoon shift. Any other questions? Surface conditions. Brent just asked a question. So surface conditions can be damp. It just can't be wet. So if you have any beads of water or any, so again, just blow it off or brush it off. It can be damp. Most substrates, it will the DefendAir 200 will go on primerless without a primer. As is. Warranty. This is, again, backed by Dow Corning's general product warranty. In isolation, it could be 10-year warranty. It can be if you want to use the whole system, which is why we're calling it the Build a Better Barrier system. You use the weather seals, you use the 778 liquid flashing, you use the STS silicone transition system, and the DefendAir 200. And you work with our technical team to ensure that the details are in line with your expectations. An opportunity to provide a warranty of up to 20 years can be achieved. Again, that conversation we encourage, if you're looking for that kind of warranty, that conversation should take place early in the project stage, not towards the end when they're trying to button up the project. Any other questions? Again, if something comes up in your mind that you want to seek some clarification as you're walking around the show, Dow Corning Corporation, myself, Brent, and our colleagues from Dow Corning are all at booth number 926, where we have another mock-up that's all dry, and you can see all the components working together. And yes, you can touch it without having to kind of wash up after, like I did over here. So, if there aren't any more questions, thank you very much, and enjoy the rest of the show. Look forward to seeing you at our booth 926.